All right, so now we have some important theorems. The first one says, if a line through the center of a circle is perpendicular to a chord, then it bisects the chord. So if a line through the center of a circle, so we have a line through the center of the circle, and it is perpendicular means makes 90 degrees, with a chord, then it is bisecting or cutting that chord in half. So each of these halves are equal to each other. Now, these is kind of saying the same thing, but backwards. If a line through the center of a circle bisects the chord, so if we know this is being bisected, then those two lines are perpendicular to each other. And then the last one, the perpendicular bisector of a chord passes through the center of a circle. So if we know we have a perpendicular bisector, then we know it's going to be passing through the center. So just kind of variations of each other for these theorems. So for example 2, it says, consider circle G with TU perpendicular to IJ if TU equals 24. So this whole length here is 24. SU is 5. So this little bottom section over here is 5. Find IJ. So IJ is this section over here. Now, we don't have a lot of information. So you guys might be saying, like, what in the world are we going to be doing here? But they actually gave us the diameter. So TU is our diameter. And we know if we have the diameter, our diameter is just going to be double our radius, or our radius is going to be half of our diameter. So half of 24 would mean our radius is 12. Now, why is that important? Well, because I can draw a radius anywhere I need to help me. So what we could do is we can take our radius, which is going to be 12. We can take our radius, which is going to be 12, and apply it to half of our diameter. So that's going to be this section over here. Then I know this whole length TU is 24, so I want to figure out what like this section is over here. So 12 plus 5 is 17. So 24 minus 17 is going to be 7. So that means this remaining section is 7 right here. Okay. Now, what I can do from the center is draw another radius. So that radius again is going to be 12. So now what I have going on is I have this kind of altitude 7, this radius 12, and then I'm going to find IS over here. So this is my ISG triangle, ISG. So this is like my X. So I can use Pythagorean theorem here since we have a right angle. So I can do x squared plus 7 squared equals 12 squared. I get x squared plus 49 equals 144. Subtract out my 49. I get x squared equals 95. And then when we square root this, I get the square root of 95. So let's see what that is. So 144 minus 49 was 95. Square root of 95 is going to be 9.7. So x equals 9.7. Now that was just IS. I want IJ. And I know IJ is bisected, so that means each half is the same. So we're going to do 9.7 plus another 9.7 for my IJ. So 9.7 plus 9.7 is going to be, let's see, 19.4. And that would be our length. Now for the second one, in circle C, CH is 3, so let's label that. HE is 2. Where's HE? 2's over here. Find the length of CG. So C to G is over here. So that looks like it's a radius. DE is my diameter. FH is a chord, or half a chord, I should say. And FG is that whole chord. All right. So right away, I know that this to this is also a radius. So CE is a radius, and that's going to be 2 plus 3, which equals 5. So my radius is 5. That means CG is going to be the same because it's a radius. So that radius is going to be 5. Then we can find my diameter, which is DE. And diameter is just double your radius. So that's going to be 10. So DE is going to be 10. Then what we can do is you can find FH next. So if I know my radius is going to be 5, that means FC is going to be 5 as well. So then I can draw my triangle situation here. So I'm going to do FHC, where HC is 3, FC is 5, and then this is my x. So x squared plus 3 squared equals 5 squared. We get x squared plus 9 equals 25. Subtract the 9, we get 16. And then square root to get x by itself, and we get 4. So that means my FH is going to be 4. And then my FG is just double that, so that's 8.